friends, welcome to the first chapter of shapes, in which we are going to see a circle and its parts and how to draw a circle. Well, in day-to-day life, we see many things which are perfect circle in the shape. For example, bangle, cap of a bottle. Many a times the packing boxes which we see, which are the perfect circle in the shape, cap of jars, and an important thing, we find that the wheels of vehicles, they are in the shape of a circle. Well, the uh, development and finding of the circle is invention of will in the history of humans is an important milestone in the development of humans. So let's start with the what are the different parts of circle, because the circle is an important shape in the human life. So first of all, I am going to use a cap of a jar for tracing or drawing a circle. We'll cut that circle out of the paper and we'll see what are the different parts of the circle. So first of all, I'm going to trace a circle with the help of the cap of a jar. I trace a circle on the paper. Then I'm going to cut it out from the paper. Start. Now we have a circle which is cut from the paper with the help of a cap of a jar. I'm going to fold it in such a way that half of a circle will exactly overlap the remaining half of the circle. So we will get the center line of the circle. Now, at the same time, again, I am going to fold the circle for one more time in such a way that the remaining half of this circle will exactly overlap the half of the circle. So we will get another center line of the circle. Now, so we get two creasing on the circle. One is vertical, another is horizontal. I am going to draw a line on these two creasing and let us see what we find. So with the help of a scale and a marker, I am going to draw a line on the circle, on the creasing. These two lines intersect each other at a point. Not only they intersect each other, they are going to cut each other in two equal parts. So these two lines, they are bisectors of each other. Means this part of a line and this part of a line are exactly of the same length. This part and this part will be of exactly the same length. In this case, the point at which they intersect each other is known as the center of the circle. So O is this center of circle. So we got the center of the circle as O. So what is the center of a circle? Center of a circle is a point which is at equidistance from all the point on the circles. So from this point, this is at the same distance. From this point, this is at the same distance. From this point, same distance. This point, same distance. This and this. So this is the center of a circle, or I can say that all the points which are on the circle are at the fixed distance from the center of the circle. So center of a circle is a fixed point from which all the points on the circle are at the same distance. Now these two lines, they are exactly dividing the circle into two equal parts. So if I name the line segment as AB, this line segment AB is going to divide a circle into two equal halves. So line AB is known as the diameter of the circle. And line segment O to B means a line segment joining from the center of the circle to any other point on the circle is known as the radius of the circle. So here the AB is the diameter of the circle, OA is the radius of the circle. So we got that from this, that AB is a diameter line segment AB. The segment or the part of a line we are showing by dash, heading dash. Line segment AB is known as the diameter of circle, and it's shown by alphabet D. So diameter is shown by D, where OB or OA, OB and OA, which is same distance from the center, it's known as radius of circle, and it's shown by small alphabet R. Many a times for diameter capital D and for radius capital R are also used. Now we are talking about the another line segment CD. Whether CD is equal to AB? Yes, CD is equal to AB, which is also the diameter of the circle. And we can see that OC, line segment OC and line segment OD are also the radius of the circle.
Start.
So any line that is joined from any line segment that joins a point on a circle and passing through center O, and joining another point on the circle. So any straight line segment that's joining one point on a circle to the another point on the circle and passing through center O is known as the diameter of circle. And diameter is twice the radius. So this is the relation between the diameter and radius, that diameter is double the radius, or radius is half the diameter for a circle. Let us see what happens if I am going to join a point on the circumference or the outer line of the circle and to any other point on the circle. Say this point be P and another point be Q. If the line segment is joining the points P and Q, then such a line segment is known as a chord of a circle. While if I take any other point in between P and Q on the circle, and say suppose the point B PQR, so if I am saying going by the path from P to R to Q, so this part of circle is known as the arc of circle. So your PRQ is nothing but the arc of a circle, and it's shown by like this. So it's not necessary that the arc of circle will be this only. If we go through this path P, then S and Q, so PSQ is another arc for a circle. So we have two arcs for a circle, PRQ and PSQ. Let's draw one more line segment which will join a point on a circle to the another point on a circle, say points A and B. Again A and B will form the chord of the circle, while if I take any other point in between A and B on the circle, and if I go through the path ACB, then ACB will form the arc of a circle. Now, if you take a close look that this AB, which is the chord of the circle, and here a chord of circle, that is a line segment which is joining 2 points A and B on the circle and passing through the center, is the longest chord of a circle. So diameter is the longest possible chord for a circle. We cannot draw a chord for a circle which will be of a length more than the diameter of the circle. Let us try to draw another chord which will be possibly maybe greater than the diameter of the circle. No, it's not possible to draw a chord which is greater than that the diameter of the circle. So keep in mind, diameter is the longest possible chord of a circle. One more circle, and we'll take 2 points on the circle. We'll join these 2 points from with a straight line segment. I am saying line segment and not a line because the chord is a line segment. A line is a figure which extends to the infinite distance, unknown distance for the both side from a particular point on the line. So this is a line segment. It is a part of a line. So let's take a part of a line, say x and y on the circle. Now if I take a look at this part of the circle, the part of a circle which is bounded by the chord of a circle and the arc of a circle, which is the arc of a circle, x, y and z. So the part of a circle which is in between the line xy and arc x, z, y. So arc x, z, y and line segment xy. This part is known as a segment of circle. So a part which is bounded by the chord of a circle and the arc of a circle is known as a segment. Actually, a chord is going to divide a circle into two different segments. One is a smaller one and another is a bigger one. So this is known as a minor segment and this is known as a major segment. So this part of a circle is a major segment and this is a minor segment. Now take a look at a circle with center O. Now if I take a point on the circle, say point A, and any other point B on the circle, if I join the line segment OA and line segment OB, then the part of a circle which is bounded by the two line segments OA and OB and the arc AB, or I will say arc ACB. So this part of the circle is known as sector of circle. So sector of a circle is like a piece of a pizza. So if you take a piece of a pizza or a piece of a roti, so it's like a sector of circle. So by this we are going to divide the circle into sectors. We will see that there are two sector forms. One sector which is formed by AOB and the arc, so inside sector, and this is a larger sector. So this is known as a minor sector and this is known as a major sector. But this is afterwards we are seeing in the higher classes. But keep in mind, is sector is a part which is bounded by two line segments, that is two radius, two radii. Radii is a plural of radius. Means when we are saying more than one radius, it's a radii. So when we are talking about radiuses, it's not radiuses. So AOA and OB are radii and ACB is arc. So OA and OB, I am saying that they are radii, which is a plural for radius, and ACB is an arc ACB. So this part is bounded is known as a sector. So let us cut out this sector so that we can easily find out which part is a sector of a circle. So I am going through the radius. So this part bounded between the two radii of the circle is known as the sector of circle. On the other hand, if I take out a chord of a circle, and then this part is known as a segment of a circle. Now let us see what is meant by the circumference of the circle. Consider a circle with center O. Now if I start from a point on a circle and go around the boundary of the circle in the circular path, in the either in the clockwise direction or in the anti-clockwise direction, but along the boundary of this circle, I will complete a distance. This distance is known as the circumference of the circle. So circumference of the circle is the distance or the length of the boundary of the circle. In short, circumference is the length of the boundary of the circle. So once again, I am going to repeat all the concepts. So if I take any point on circle A, if I join point A with center O, then this is known as a radius. If I join from A to any other point B on the circle, but this line passing through center, then AB is known as the diameter of the circle, and OA and OB are the two radii or radii of the circle. Then if I joined any 2 points on the circumference of the circle, for example, if I join X and Y, then X and Y is known as the chord of the circle, while if I go in the circular path from X to Y, for example, I go through the circular path X, Z, Y, it's known as the arc of a circle. Then if I take one more point, say point C, on the circumference of the circle and means boundary of the circle, then the part of the circle which is bounded between radii OC and OA is known as the sector of the circle, and the part which is bounded by chord and the arc XZY is known as the segment of the circle. Let us solve one problem which is related with the different parts of the circle. It's said to find out the diameters which are there in the given figure. So we can see that line segment AC and line segment BE, they are passing through the center of the circle and they are joining 2 points on the circle. So AC and BE are the two diameters in the given figure. Now it's said that to find out which are the different radius we find in the figure. You can see that O is the center of circle. So all the points which are joining from the center with any point on the circle, for example OA, OB, OC and OE are all the 4 radii of the circle. So OA, OB, OC and OE all are the radii of the circle. Can this EB be the radius of the circle? No, not at all. Now we find the center of the circle. It's said to find what different chords we find in the given figure. First thing, chord is a line segment which joins any point on the circle to any other point on the circle. We'll see that EB is one of the chord which joins 2 points on the circle. Then BC, DC is another line segment which joins the 2 points on the circle. However, don't forget that the diameters are the longest possible chords of the circle. So both the diameters AC and BE are also the chords of the circle. Then it's said to find out the arcs of the circle. We can find that this APB, arc APB is arc of a circle. It's minor arc of the circle, while AQB is a major arc of the circle. So AQB is a major circle. Then we can find that DQC is another arc of a circle, while DPC is one more arc of the circle. Also, we are having AEQ, then BCQ. We are having many arcs, so we can draw any number of diameters, any number of radius, any number of chords, any number of arcs on the circle. So we can draw infinite number of diameters, radius, chords, arcs on this circle. Be careful that only one center we are having for a circle. Then we have to find out the segment. How many segments we are having? You will see that the segment is the part which is bounded between the chord and the arc. So we will write down that APBA is one segment. APBA is one segment. And secondly, we are having DQCD. So this is DQCD is another segment. Do we have any other segment? Yes, we are having another segments. For example, semicircles are the two possible segments. Sector. Sectors are the part of the circle which are bounded by the two radii of the circle. We can see that OA and BO, they are binding some part of the circle in between them. So we are having APBO as a sector. So APBO is one sector. Then BOC is another sector. BOC, but we should have one more point for locating sector in between them. So we can give this point as X. So BXCO is one more sector. CQEO is one more sector. CQEO is one more sector. We can draw a number of sectors on any circle.
Right.
Now we will see how to draw a circle using a geometry box. What are the different instruments we find in the instrument box or geometry box is we mainly get this compass, a scale, a protractor, two set squares we are having, and a divider. Other parts which are available in the geometry box are pencil, eraser, sharpener, but the major important parts of the geometry box: compass, protractor, scale, and set squares. Major component which is used for drawing the circles in the compass box is the compass itself. What are the different parts of the compass are two legs. One have a pointed, another is having a pencil holder. The use of pencil holder is to hold the pencil so that we can hold the pencil firmly in the pencil holder with the help of a screw. So another important part of compass is the hinge. Hinge is nothing but a screw which is joining two legs of the compass. This screw especially is used for fastening or losing the legs of compass, so we can control the movement of the compass. So if you don't want to move these legs very fastly away from each other, just tighten the screw, you will control the movement of the compass. Now let us see the problem which is given is to draw a circle of the radius 4 centimeter. So to draw a circle of a radius 4 centimeter, we are going to start with the help of a compass. First of all, we are going to hold a piece of a pencil in a compass, hold in the pencil holder firmly so that it will not move. Secondly, we will try to keep the pointed end of the leg of the compass and the tip of the pencil on the same level. Be careful that the pencil, you should not hold it uh, far, far above or far below. So this will give a trouble while drawing a circle. So be careful that both the points of pencil and leg should be on the same level. Next thing, it said that to draw a circle of a 4 centimeter. So we are starting to draw. First of all, we are going to draw the given radius of 4 centimeter. So we are going to draw a line segment of 4 centimeter length, exactly of 4 centimeter length. We are going to give one end of this as O, which is the center of the circle, and another end as A. So OA forms the radius of circle. Now with O as the center, we are going to keep the tip of the compass on O, and we are going to align the point of pencil with A so that the distance between the tip of the compass and the point of a pencil will be 4 centimeter. Now we are having a radius of the distance equal to radius of compass in between the 2 points of the compass. We can draw a circle easily. Now this going to maintain a constant distance of 4 centimeter in between the tip of compass and tip of pencil. So every time we are getting a distance of 4 centimeter, and this is the definition of circle, that every point on the circle lies at a fixed distance from the center of the circle. So we are getting a figure in which all the points are at an equal distance from the center O. So our required circle is with center O. Next problem we are having is to draw a circle with a diameter 6 centimeter. In initial problem, the radius was given, now the diameter is given. When the diameter is said, we know that the diameter of circle is double that of radius, or radius is half that of a diameter of the circle. So we will take half of 6. Half of 6 means 6 divided by 2, 3 centimeter. So the required radius of circle will be 3 centimeters. Now with the same thing, that we are going to locate a point on the page which will form the center of the circle. We are going to draw a line segment of length 3 centimeter, which will be equal to the radius of circle. So OA will now form the radius of circle with the tip of compass on O and the point of pencil on A. We got the distance equal to the radius of circle in the compass. Now we are going to trace or draw a circle. So this is our required circle of 3 centimeter radius. Our next problem is to draw the circle of radius 4, 5 and 6 with one center or common center. Will it be able to draw a circle with more than one circle with the same center? Yes, such circles are known as concentric circle. So first thing first, we are going to locate the required center. Then we are going to draw the line segment of the required length. For example, it is said as 6. So we are going to draw a line segment of radius of a length 6, so which will form the radius of one circle. Now we are going to trace the another radius which is given as 5 centimeters on the same line segment, and the radius of 4 centimeter on same line segment. So all the three radius are here. Now we are going to give the names as A, B and C, and center as O. So with center O and distance equal to OA, which is equal to 6 centimeter, we are going to draw a circle. Now with distance equal to OB in the compass, we are going to draw another circle, and with distance equal to C in compass, we are going to draw the required third circle. So the smaller circle will be of 4 centimeter radius, the middle one is of 5, and the outer one is of 6 centimeter. So all these three circles are having same center, and these are known as concentric circles.